Just because a lot of just because the machine learning or artificial intelligence is booming, it is not that we are going to solve all the problem using artificial intelligence. Okay, so there should be a clear problem statement. So as part of the problem statement, we just understand what are the pain points and what is our focus. Okay, so here in this case we want the objective of this project is they want to predict the salary of the faculty members in the case of college, right, based on various factors like rank, discipline, years since PhD, years in service, and gender. So these are the three, four, five columns are there, right, in my data set. The goal is to understand the impact of these factors in on salary determination and build a predictive model that can be used for salary estimation. Okay, the salary for the employees are determined by various factors, right? The based on their education, based on the experience, and maybe right in some colleges like here we say University Grants Commission. They have a separate rules and regulations, right? So since years since PhD, the number of years since PhD, that one plus how many number of years they've experienced, and again gender also, right? Gender, and then the discipline, which discipline are they into? Okay. So based on various factors, the salary is determined for each employees. The whole idea of creating the machine learning model here is to understand the impact of these factors like years in service, gender, discipline, rank, and years in PhD on determining the salary. Okay. So to do this, right, to determine the salary, what we are doing is we are building a predictive model using which the salary can be estimated, okay, using which we can estimate the salary. So in this case, the goal is business objective is they want to understand, the university or the institution wants to understand the salary distribution across different faculty members and predict future salaries. This is the business key business objectives. The here what we have done is, right, we want to convert this into a machine learning problem. So this is a problem statement. We want to convert this into an analytical or the machine learning problem. Okay, the business objective is want to understand the salary distribution across different faculty members and predict future salaries. Okay, so here we need to first define the target variable and independent variable in the given data set. The target variable is salary. It is a continuous variable. Remember that. And then the independent variables or input features or the rank, discipline, years since PhD, years in service, and gender. So we have five input features and one target variable or the dependent variable salary. Okay, the salary is depending on various factors. Okay, so here the rank is a categorical variable and discipline is also categorical variable. In the discipline we have two categories, whereas in the case of rank we have three categories: assistant professor, associate professor, and professor. Years since PhD, this is also continuous variable, numeric variable. Years in service also numeric variable. Gender is a categorical variable. The gender contains only two categories. Discipline also contains two categories. Rank contains three categories. In total, we have three input features or categorical and only two features are continuous. As we all know, in the case of regression problem, we need to train our regression models regression models only if all the independent variables or input features are numerical. But in the real world we get the mix of both numerical and categorical variables. Okay, so in that case, how do we deal with that? How do I fit my independent features, or how do I fit my model? Okay, so in that case, all the categorical features that needs to be converted into numerical features. So in that case, yeah, so okay, that is the one we need to do it. Since how do I decide which model should I use it? Okay, which model should I use it? Or can I use the classification problem related algorithms or regression related algorithms like linear regression or decision tree or XGBoost, something like that. Okay, Since in this case, the target variable salary is continuous, it is pretty clear. We can use linear regression model to model the relationship between salary and predictor variables. The whole idea is you want to model the relationship between salary and predictor variables. So next one is, here is the mathematical representation. We know what is the linear regression equation, beta naught plus beta 1. But in this case, it's a multiple linear regression. We have 5 input features: rank, discipline, years since PhD, years since service, gender. So here, hence, we have 5 input features. For each feature, we have different coefficient values: beta 1 into rank, beta 2 into discipline, beta 3 into this. Beta 1, beta 2, beta 3, beta 4, and beta 5 are your slope, and beta naught is your intercept. Next one is, the next step is model training. Okay, the next step is model training and evaluation. So we train the linear regression model on the given data set. And then what we do is, we will evaluate the model's performance using the mean squared error and the other metrics called adjusted R squared. Using these two metrics, we are going to evaluate the model performance. Is it clear? Okay, so to conclude that, using linear regression model, we can determine which factors significantly impact the salary and use this same model to predict the salaries for new faculty members. If in case of any new faculty member joins my university or institution later point in time, with this trained model, I'm going to apply this on the new faculty members to estimate their or determine their salaries. Okay. So now, now in this case, right, the first step is we need to ingest the data. What do you mean by ingest the data? Load the data into my data frame. Okay, load the data into my data frame. Next step is the data pre-processing and the feature engineering. What is data pre-processing and feature engineering? Data pre-processing is something like if you have any duplicate records or any missing values are there in your data set, or anomalies, something like outliers are there, you need to address it. Okay. And also, right, you need to do some kind of feature engineering. What do you mean by feature engineering? What is the difference between data pre-processing and feature engineering? Data pre-processing is something like data cleaning. Okay, and then the feature engineering is something like, based on the existing feature, we are going to create new features, the input features. I'm talking about input features. Okay, what do you mean by creating new features based on the existing feature? For example, you have a column by the name of age. So your customers' ages, starting from the teenagers to till, the 100-year-old customers. Okay, in this case, you wanted to have a categorical column in order to perform some analysis later point in time to understand which which age group of people are purchasing which items, which all products, and what are their priorities. Okay, based on the age group. Okay, so what for that we are creating some kind of age group category, something like that. So there, what we do is we derive this age column based on some range of values or intervals. For example, all the teenage customers, we group them as under teenagers, and those customers are above 19, let's say 20 and 25. We flag them as young customers, very young customers, and 25 to 35 young customers, and 35 to 45 we are middle-aged people, and 45 to 55 or 45 and above, right? We call them as old and very old customers. So later point in time, if you classify your transaction based on these categories, you can find out how many number of senior citizens they bought a specific product. Okay, What are their priorities? In the case of senior citizens, what are their priorities in terms of spending money on your store? And also teenagers, what items they purchase more frequently, how much money they spend it. Okay, you can do that kind of things. For that, what you do is you can use the existing age column, which is a numerical or numerical column. You are creating another column which contains the categories. That is called feature engineering, creating a new column based on the existing columns. It is also called as a binning, binning, binning or bucketing or binning. It is all right. That is how they call it. So yeah. So in the case of our example, we have a column called rank, and the discipline, and then gender. These three columns are input features or categorical. The rank column contains the assistant professor, associate professor, and professor. I just write it here. Just give me a second. I need to take my pen and just write it here. So my rank column contains assistant professor, and associate professor, and professor. Yes, some employees are professors, some faculties are professors, some faculties are associate professors, some faculties are assistant professor. Okay, so here this rank column contains three categories in it. Gender column, obviously some professors are male and some professors are female. In general, gender column contains only these two unique or distinct values in it. But in the rank column, these three distinct values are there. And then you have a discipline column. The discipline column, you have, let's A, B, or field A, field B, something like that. Okay, only two categories are there here. Since these three features are categorical by nature, it requires some kind of feature engineering. Because as per the rule of thumb, all the input features supposed to be numerical. What we need to convert these three categorical columns into numerical column. That task is called feature engineering. Okay, so in this case, we are going to create some new columns based on the existing columns. Okay, based on the existing columns. Okay, for example, in the case of rank, right, we need to do some kind of one-hot encoding. So what do you mean by one-hot encoding? First of all, what is encoding? We replace these values by zeros and ones, or 1, 2, 3, something like that. Okay, either you can replace these values. For example, here male female is there. Male conventionally we use the value as 1, and female 0. Instead of mf or male or female, whichever records related to male, we put 1. Whichever faculties they fall in the female category, we'll put 0. Is it clear? Similarly, in the case of discipline, whichever employees or the faculty members that falls in a discipline, we put 1 or 0, something like that. Okay. And next one, rank. In this case, but in this case, we have three categories are there. If you have only two categories, you can put 1, 0, 1, 0. But here we have three categories. What can we do? So there are two types of encoding. Now you understood what is encoding. Encoding is replacing the categorical by some numerical values. Numerical in the sense, usually we use the binary encoding, 0 or 1. But in some cases, we assign 1, 2, 3, something like that. We replace the categorical values by 1, 2, 3, something like that. So there are two types of encoding. So one is the label encoding and other one is one-hot encoding. What do you mean by label encoding? What do you mean by label encoding? Yes, right. When the categorical variable in this case the rank, has a natural ordinal relationship, low, medium, high, right? So in that kind of situation, you can go for the label encoding, low, medium, high. It has some inherent order in that variable. So the high priority tasks are much more important than your medium priority tasks. Medium priority tasks are much more important than your low. But there is a superiority and inferiority, right? Comes into picture. So, okay. So when the model can learn from the order of categories, in that kind of situation, we need to label encoding. Simply put, 1 to 0, 1, 2, 3, something like that. Okay. The problem is it introduces an artificial ordinal relationship, even if one does not exist. For example, model assume that Professor 2 is twice, as important as assistant professor. For example, here in this case, if I use label encoding, see label encoding, when you are supposed to use it, supposing the column that contains something like something like severity level. Severity. There is a column in your data set like a severity level, right? You have high, medium, low is there. So in that kind of situation, you can use 1, 2, 3 and all. Instead of high, medium, low, you can put 1, 2, 3. But if you wherever 1 is it, that means high priority task. Wherever 2 is it, that means medium priority. Wherever 3 is that is low priority tasks. Okay, fine. Here there is a, so in this column, severity level, inherently contains some kind of order in it. 1 is superior than 2, 2 is superior than 3, because you need to give utmost importance to 1. If you are in a support project, right, the severity level 1 is within 1 hour time that issue needs to be resolved. 2 means within 3 to 4 hours needs to be resolved. If it is 3, maybe, right, we can take 2 to 3 days or 1 to 3 days. 1 to 3 days we can take to solve the problem. Okay, there is a criticality, right? So see, the criticality based on the severity level, we are going to determine which task needs to be which issues needs to be fixed when. But when it comes to one hot encoding, okay, so if you have a nominal type of variable, so the rank is kind of nominal type of variable. So here also you can assign, right? For example, here you can assign professor is 2 and assistant professor is 1 and associate professor is 1, 0, 1, 2. You can specify this way. Instead of specifying instead of specifying 0, 1, we can specify 0, 1, 2. But since we are specifying 0, 1, 2, it's something like a rank, right? It is not like uh, it's not like if I say if I assign value 2 to the professor, I replace the value professor by 2 and associate professor by 1 and assistant professor by 0. It doesn't mean if I assign 2 to professor, so professor is twice as important as assistant professor, which is incorrect. There is no superior to inferior, right? It's not that professor is twice as important as this guy. It's not that, there is no order comes into pictures. In that kind of situation, we need to use one hot encoding. In case of the categorical variable that contains or that inherently has some order in it, then you can go for label encoding. In case of nominal type of variable, we discussed about the nominal and ordinal type of variable in the as part of descriptive statistics. If you recall that, so we are just simply labeling the values here. Okay, so ordinal type of variable is something like inherently it has some order, but here there is no order here. Okay, the one hot encoding, it converts each category. It converts each category into 0 or 1 only. 0 or 1 only. Okay. So in this case, what will happen is I just show you my. So it will be something like that. So I have a column called rank. In that rank column, I have three categories: assistant professor, associate professor, and professor. So what I do is, since there are no uh, order exists inherently, I'm going to use one-hot encoding technique. So label encoding, already I told, in case of any inherent order, inherently any order, is there in your given data set, then you can go for label encoding. Since the rank column does not contain any order in it, hence we need to use an approach called one-hot encoding as part of your feature engineering. The feature engineering, based on the existing column, we are going to create additional columns. One simple example, for example, you have an order date column and you wanted to maintain the order, sorry, year alone in a separate column. You create a year column separately. That column will contain only the year information: 2024, 2023, 2022, something like that. So based on the order date column, you extract the year from the order date column and then you store it in a separate column. That is also another example for feature engineering. In this case, what we are doing is, in the single column, rank column, or the one-hot encoding, right? So what we are doing is, for example, this staff, the first record, right? For example, Ramanathan, he is an assistant professor. Ramanathan, his age is, let's 45. Ramanathan is an assistant professor, and his age is 44, and his education is so and so, and years of service so and so, and he is a male and his rank is 1. In this case, it will create behind the scene 3 columns when you do feature engineering using one-hot encoding. So what happens is, it will put 1 for the Ramanathan. Because Ramanathan assistant professor, it put 1. What about the remaining 2 columns here? Single column got transformed into 3 columns in this case, because we have 3 categories where there in my rank column. So what they did, so in the case of one-hot encoding, the idea is, since we have 3 categories are there in that rank column, so we create, so one-hot encoding, what it does is, this technique creates 3 different columns, each one for each category. Okay, for each category, separate feature will be created. Since the first record, Ramanathan, is a faculty member, he is an assistant professor, in his age is 45 or something like that, and he is PhD. He did PhD almost 3 years back, and he's a male. And when it comes to rank, right, 3 columns are there: rank assistant, rank associate, rank professor. In this case, it will flag 1 for this. 1 means true, 0 means 0, 0, false. So here, this is how the one-hot encoding works. If you have 0, 0 here, it inherently tells the first employee, or this record, belong to assistant professor. This staff is an assistant professor. For example, the second employee, right, is an associate professor. So in that case, it will flag 1 here. For the rest of the columns, it will put 0. For example, the third record is, Dr. Subramanian, right? Subramanian, he is a professor, hence it will flag 1, and rest of the columns it will put 0. This is how the one-hot encoding works. You might be asking this question: rank is a single column, in that I have 3 categories. Why do I need to create 3 separate columns for each category? This is how one-hot encoding works. But in this case, for example, you have a column that contains, for example, state column: Tamil Nadu, Karnataka, AP, Andhra Pradesh, MP, Madhya Pradesh, something like that. So in that case, do I need to do one-hot encoding? Yes, because none of the states are superior than other states, right? In that case, yes, you need to do one-hot encoding. You cannot do a label encoding. One-hot encoding only you can do that. So in that case, for example, you have 27 states are there. Let's assume that way, okay? 27 states, that means 27 minus 1 columns we created. So in this case, we have 3 categories. This for you to understand, I put, I created 3 columns for each rank. Assistant professor 1 column, and associate professor 1 column, and professor 1 column, right? So in reality, it will create, on the case of one-hot encoding, it will create n minus 1 columns. That means, for example, if I have only associate professor and professor, n minus 1, three categories, minus 1, 2 categories, right? N minus 1 columns we are going to create based on a single category column for the one-hot encoding. So rank contains 3 categories, hence 3 minus 1, 2, only 2 categories. In reality, we will be creating it. Just for you to understand, we put 3 categories also here. Supposing, right, this first record as Ramanathan, he is an assistant professor. But if you keep only 2 columns, if you don't specify here, what will happen? So these two are, this guy Ramanathan is neither an associate professor nor a professor. That means he's an assistant professor. Now you might got some confusion, right? So man, sometime you are saying, one second. Sometime you are saying 3 columns, it will create a 3 categories columns. This is for the sake of understanding, right? I told you. Okay. If we have a categorical column and if you have to do one hot encoding, behind the scene, what happens is it will create n minus 1 columns for the categories. If you have 3 categories, in this example, we have 3 categories, it will 3 minus 1 is 2, 2 columns will get created. So what about the other column? For example, associate professor, I just repeat it again. So what happens is in this case, right, still you can make out, right? Without this column also you can make out. If you have only 2 columns, if you mention 2 columns in this case, in this context, the 0, 0 means he is neither a professor nor a assistant. That means he's an assistant professor. Then why do I need an additional column? What if I keep 3 columns? I'm not going to lose anything. The whole idea is, right, we wanted to reduce the number of the features. If you have more number of features, it will slow down the performance. Okay, more number of features, it will slow down the performance. Just assume that you have a state column and 27 states are there. In that case, it will create 27 columns for each category, right? Each category is nothing but each city or state, right? So instead of 27, 27 minus 1, 26 column. Okay. For example, right, we have, let's say we have only 3, in our company, we have only 3 departments are there. 3 departments are there. Department A, B, C. I belong to department B. Okay, I can say this way also, right? I am not part of either the department A or department C. Okay, so in that case, what does it tells you? See, we have 3 departments, department A, B, C. Okay, so I belong to department B. I can say that way. So in that case, the rest of them will be 0, right? Or I can say this way, I don't belong to department A or department C. So in that case, I obviously belong to department B. Since I don't have to tell this explicitly, if I keep only 2 department column, so in that case, what will happen is, see, basically how it works is, we'll put A, B, C, something like that. So let's say if I say I belong to department A, 1, that means I'm not, I don't belong to these 2 departments. Hence, I put 0. 0 means false. 1 is true. Okay. So instead of saying this way, I say, different way. I neither belong to department B nor I belong to department C. That means, right, I belong to department A. Why should I tell explicitly? So in that case, I'm going to knock off this value or this column so that I'm end up having only 2 columns in it. This is to reduce the number of features. Okay. Dimensionality reduction. Dimensionality reduction. Dimensionality reduction. Okay. As part of feature engineering, we have explored the types of encoding. And as part of the types of encoding, there are 2 types. One is the label encoding, other one is one-hot encoding. In the case of label encoding, if the categorical column, the categorical column is inherently has some order in it. Some order in it. then I can go for label encoding. Okay. But in the case of rank column, rank is not, it doesn't contain inherently any order in it. Hence, it's a nominal type of variable. So in that kind of situation, we can use one-hot encoding. Since in the case of rank, we have assistant professor and associate professor and professor, right? So three categories are there. For three categories, I call this an n minus 1, columns needs to be created. Okay, n minus 1 columns will be created. So in that case, what will happen is, based on the alphabetic thing, right? The first one will get dropped. Only the remaining two columns will get created. So if somebody says, listen, in your data set, in addition to all the columns, you will have associate professor column and professor column will be there. So here, let's say, the first person, first record, right? So the name is Rom and age is 45. And if I say this guy, neither an associate professor nor a professor, that means Ram is an assistant professor. That's all. We know very well, only three ranks are there. Okay, so this, but the disadvantage is later point in time, if you are going to introduce additional thing, right? There will be some kind of confusion. Okay, but even if you do it right, for example, assistant professor, person, head of the department or something like that. So we have four categories. 4 minus 1, 3 columns needs to be created. That's all, guys. So in that case, what will happen is, at least you are trying to minimize the number of input feature columns. So now, you see, basically, why we need to convert these are three different, or let's say two different columns. Single column, we have the reason is, all these input features are supposed to be numerical, so that's the reason we are doing it. Here we are, so why do we need to use 0, 1? And instead, can't I use 1, 2, 3? I explained already. If the column contains the values that are inherently has some order in it, then you can put 0, 1, 2, 3. But since rank is not inherently containing any values that has some order in it, it is obviously a nominal type of variable. For the nominal type of variable, you need to create one-hot encoding. On top, make sure that you create n minus 1 columns for the n categories. The n categories, the number of categories are 3. 3 minus 1 is 2. So create only 2. That is how it works. Okay. So when to use one-hot encoding, when the categorical variable is nominal, which means no natural order. When there are a few unique categories, not too many unique values. That is also you need to keep in mind. So again, you might be asking this one. You said state. So state we have contained almost 27 states. So and that let's say, and you have 1 million transactions, then that is okay. And let's say you have few unique categories. And for example, zip code is too high, right? In that kind of situation, we need to use some other technique. You cannot use one-hot encoding, okay? Because you will end up with so many input features. So increasing the number of features also leading to something called curse of dimensionality. We call that as a curse of dimensionality. Dimensionality, curse of dimensionality. If the categorical variable has too many unique values, you will end up with a situation called curse of dimensionality. Okay. So to conclude, you can use label encoding when the categorical variable has an ordinal nature and fewer categories. Label encoding is the best fit. You can use one-hot encoding when the categorical variable is nominal, which means no order and has a small number of unique values. Then you can go for one-hot encoding. So in this case, obviously, number of unique values are fewer here in the case of rank, and it is also a nominal type of variable. What we do is we can go ahead and use this technique one-hot encoding. Okay, this is how it works. Okay, this is how it works. Whichever records you flag that as a one, but that means he's a assistant. So in this column, right, whichever record you flag one under assistant professor, that means that guy is an assistant professor. And whichever record, right, of these three columns, if you put flag one, that faculty member is an associate professor, something like that. Okay, remember this. Yeah, we have something called get dummies function, and apart from this, we have something called column transformer, using which also you can do it. But that is what we have seen it in the last session. That is little bit difficult for you to understand at the since you are a beginner, right? It will take time for you to understand. Instead of that, you have something called get dummies. In the pandas package, there is something called pd dot get underscore dummies. There is a method or function that is available. Okay, and this is the one will help you to convert your categorical variables into numerical form using one-hot encoding. But importantly, in the get dummies, right, you have an option called mm, uh, drop first. First is equivalent to true. You need to specify that. So you have an option, okay, here. So as part of this, you need to specify your data frame name and then the column name, okay, column in this case rank, and then drop first equal to true. That means the assistant professor, you can drop it as per the alphabet, okay? It will drop the thing, and then you are left with, two columns will get created, and these two columns will have 0, 0 for those employees belong to assistant professor, and those employees belong to professor. It will put 1 here, and here the rest of them will be 0, right? The rest of them will be 0, 0. That means this guy an assistant professor is not an associate professor, nor is a assistant professor, right? If first of all, this column will not be this, right? That is how it works. So the get dummies function, it converts your categorical columns into multiple binary columns. Each category gets its own column. That is what you need to remember. And also, right, remember that a row has one, if it belongs to that category, okay, otherwise 0. So what is drop first equal to true? It drops one of the newly created binary columns to avoid the dummy variable trap, okay. So dummy variable trap, what do you mean by dummy variable trap? Why do we need, so other reason why we are dropping one of the, newly created binary columns, right? To avoid the dummy variable trap. So this basically, right, it can introduce multicollinear linear regression models, okay? So this ensures only n-1 categories. This to, and also to prevent the redundancy. For that reason, we are using this one. So, one second. So in this case, right, before encoding, this is your rank, assistant professor, and associate professor, and professor, something like that, okay? So this employee IDs, 1, 2, 3, something like that, okay? And after one-hot encoding, without drop first equal to true, you will end up 3 columns. Without drop first equal to true, okay? After one-hot encoding, with the drop first equal to true, you will end up only with the two columns, okay? Associate professor and professor, this column will not be there. So 3 things. One is before encoding and after one-hot encoding without drop first equal to true in your pd dot get dummies function df comma rank comma true, right? So without this one, right? Without drop first equal to true, you will end up something like this. And with one-hot encoding with the drop first equal to true, you will end up something like this. Only 2 columns will be there. n-1 columns will be there. This basically to reduces the number of input features so that the performance will be faster. So all right, now what we will do is we will jump into the coding part, and we will see how we can use the pd dot get dummies function in order to the feature engineering. And apart from this, right, we don't have anything else to do, there. But again, the other columns like discipline and sex, even for that we will use get dummies. Okay, even for that we will specify drop first equal to true. In that case, what will happen is whichever columns that do not contains one, that means it's a female, right? So for example, whichever column that contains one, that means that person belongs to male, otherwise it is a female. Okay, something like that. Okay. So what we'll do is we'll start. I just jump into the. So we are going to use a different approach today. So this is basically to simplify your understanding and also reduce the complexity in terms of using the column transformer and all. All right. Yeah. I'm going to, this is the previous approach that we used it. So what I do is I just select everything, all the packages, right? So that I don't, we will create a separate notebook. I just create a notebook, new fresh notebook. No, the train test split should be there. So ask this question. Yeah, Priya, the train test split will be there. That is a different thing, okay? That is mandatory in the case of supervised machine learning model. Need to split your data into train test model. That is common for almost all these supervised machine learning algorithm, okay? And here import pandas as PD, and I'm going to use NumPy as NP. These packages are very fundamental package, right? So I just delete this. And I'm going to put it in this proper order. Okay, NumPy, numerical Python, and pandas. Okay, and that one. And the next one is the sklearn dot linear model, linear regression, and then sklearn dot pre-processing. And here one hot encoder and standard scalar. Apart from this, I'm going to something called. I'll explain what is standard scalar a little later. Standard scalar, and then the metrics. We are going to use metrics, and apart from this, here model selection is not there, right? Yeah, model selection is there already. I'm going to remove this one. This one is not required. And I'm going to delete this one so that this one will get. And we need to have metrics. For that, I'm going to use from sklearn.metrics import mean squared error. This is to evaluate the model performance. Comma or to score is sorry r squared. Okay, r squared value. Fine. So I'm going to hit this play button, run button to import all the packages. Okay, and let's wait for a few seconds. So you can see the star mark here. That means it is in progress. Let's wait for some time. And the next step is, yeah, instead of waiting for this, I'm going to specify the path of my data set. Even for that, what I'm going to do is I'm going to pick up from this one so that we can save time. And my keyboard is also creating some problem, unfortunately. Yes, this cell got executed successfully, no error. And I'm going to execute this one. Yes, so df data from this one contains 6 columns. Of the 6 columns, 5 columns are input features, and the salary is the target feature. since the, sorry, target column, since salary is a continuous variable, we have used the linear regression algo. We can use the linear regression algorithm to model the relationship between both the input and the output variable. Okay, and next one is what we are doing is we are going to create the categorical features. I think we have already done this one also, and I'm going to go ahead. Yeah, I'm going to use the same thing here so that we can save a lot of time. I just go here and then I'm going to separate both the numerical and the categorical column. Okay. Okay, here what I am going to do is the numerical columns, I'm not going to do anything now. So df is equivalent to, sorry, df is equivalent to, and here pd dot get underscore dummies. T is not working in my keyboard. I think some virus issue happened. Get dummies. Here, what we need to do is we need to use yeah, the data frame name. The first one is your data frame. Yes, you are correct, right? So here I'm going to use the data frame name, df. In our case, the data frame name is df, comma, columns. Columns is equivalent to the categorical columns. This is the one. Use these three columns and create the one not encoding. The one not encoding, obviously, it will have n minus 1 columns. In addition to the existing column, it will have n minus 1 columns. And then drop first equal to true. I'm going to specify drop underscore first is equal to true. And yeah, one more parenthesis required. That is for the get dummies function. We started the parenthesis here and then we ended up this one. And yeah, no, I don't think so. This is required. We will be removing it. Now what I do is I just type df. I'm going to argument followed key argument drop first is equivalent to true. Yeah. Now what happened? We already had only in total we had 6 columns. Now if you see here 3, 6, 7 columns are there. Okay. Here 6 columns are there, right? Already, including your target variable or the dependent variable, you have 6 columns. In addition to that, we have 2 more columns are there, right? So that one was due to sex male. And wherever this column, right, whichever guy, see this guy belong, is a male, hence we can see true here. And this faculty member is a female, hence it puts false. Okay, so 1 0 or something like that. Okay, and here the discipline B is uh, true. Wherever true means discipline B means it is a true. Otherwise, false. That means these faculties belongs to discipline A. Okay, and rank professor true. And you know very well the true and false behind the scene, it will be considered 1 or 0. Okay, got it? Next one is we need to define the, so for male, we have a separate column. For discipline, we have separate column. And obviously, if you see the rank, right, rank column, we have 2 columns are there. So 3 categories, 3 minus 1, 2 columns, 2 categorical columns got created here separately, right? Here, this gentleman is a male and he's a male and he is a professor. And if you scroll down and see here, this person, right, she is a female and she is neither an assistant professor nor a professor. That means this female is a assistant professor. So there is no, sorry, associate professor. This female is not associate professor, okay? So in that case, yeah, because ASST, assist professor is there. One second, in this column, Rank column professor, yeah, assoc and assist. So hence, the EASS something like that, so assist something. So in that case, what happened, it considers this is the first alphabet, okay, and professor. So here, this female is neither an assistant professor nor a professor. That means this female is an associate professor. Got it? So now the pd.getDummies function, it did a perfect job. So this is called feature engineering. This is one of the tasks of feature engineering. Okay, feature engineering, one hot encoding, we did it as part of feature engineering. The interview they'll ask you. So as part of feature engineering, what are the tasks that you carried out? So we did some kind of one hot encoding. For example, in the case of categorical column, it was a nominal data type, and we had three categories. We had to create a n-1 categorical column. As part of one-hot encoding, we did that. And we have used pd.getDummies function. In that, we made sure that drop first equal to true, because we don't want to have three columns for the three categories. In our example, we had three categories were there in the specific column. We don't want to create three columns for each categories. Hence, what we did, we have used drop first equal to true. The reason was we don't want to end up something like mm, uh, the multicollinearity issues. For that reason, we have used drop first equal to true. So now we are all set. Next step is, what are the other tasks that you did it as part of your feature engineering? And yeah, this is the one we did it. So in this case, right, what we are going to do is, yeah, we are just, next step is we are going to do data pre-processing. Okay. Here we are going to define as two variables. One variable will hold all the input features, and the other variable will hold only the target variable or the dependent variable. Okay. So I'm going to use to define features and target. Define x is equivalent to, for example, df dot drop. If I drop the target column salary from my dataset, we are left with the remaining input features only, right? Only one dependent variable is there. I need to store all the in the independent variable only in a variable called x. In that case, instead of specifying each and every independent variable, simply I'm going to drop the dependent variable, so that you are going to, this data frame will contain only the independent features, right? This is another way of doing it. Okay, df dot drop, and here columns is equivalent to salary. Second, I'll just check salary is capital S, small s, yeah. If I drop the salary column, the rest of the columns are my independent features. So the variable x will hold only the independent variables. Instead of saying independent variables, in the industry, we call the independent variables are features. Features, okay? Features means independent variables or input variables. And obviously, we need to use another variable to hold only the target variable, that is your salary. So you might be asking this question. In the previous line, you have dropped the column salary in the data frame df. Salary column has gone. We are left with only in the independent variables or the features in the data frame. Now we are using the same data frame, but how come you specify salary? So as drop function, we have another option called true or false, something like that. Okay, by default it is false. Okay, and only when you enable it true, what will happen? This column will get dropped permanently from your data set. Okay, by default it is false. What will happen in this case? It will hide this column. It will exclude this column. That's all. It will not remove it. It will exclude the column. The remaining columns will become part of your data frame. You understood, right? So this here, that is the reason why in the subsequent line I mentioned about the target variable salary inside my df data frame. That means still this column is there. Since I've used drop in this line, this column got excluded. That doesn't mean the column got dropped. Still that column is there, but it got excluded from the existing columns. Except a salary, rest of the columns were made part of your variable X. Rest of the columns were your features. Here I explicitly specify salary. So that means, this Y variable will hold only the, yes, you are correct. Yeah, here I made a mistake. Okay, fine. So the next one is another feature engineering task we are going to do, that is called standardizing numerical features. I'm keep typing. Nothing is igniting. Some problem standardizing. Standardizing numerical features. Okay. In this case, I'm using a variable called scalar is equal to standard scalar. So I'm going to initialize a class called standard scalar, and I'm going to use this an object scalar. Yeah. So now what I do is x underscore. Sorry guys, here before that, we need to split the data into train and test data set. That is one of the mandatory tasks that you need to do it. Okay. Split your training and test data set. X train, comma, x underscore train. We use this standard capital X underscore train. You can use whatever the name that you wanted, okay, to hold the training related features and the records. X underscore test and Y underscore train. Y underscore test is equivalent to train test split. Here you specify x comma y. So your previous variables, the x is holding all the independent variables or the features, y is holding your label output feature, which is your dependent variable. And then the test size, test underscore size equal to 0.2, comma, random state. Some number, okay, I just say 42 here. Split the, I just put the comment here. Training and okay, this is a training and test. 1 second, my keyboard is hanging. I just save this one so that test it is okay. My keyboard has some problem here. I don't know, test. Okay, so this comment you can ignore it. I just execute it, got executed now. So what happens here is the train test split that is available as part of your SQL model selection package or the right package and sub package of SQL and model selection. There is something called train test split method is available. The train test split method, it takes this many number of arguments. The first one is your independent variables features. Okay, x variable contains all the features and y is your dependent variable, and then test size 0.2 means you split this given entire data into 80% and 20% ratio. 80% of the entire data will be considered as my training data set. 20% of the data should be used for testing purpose. Random state equal to 42. What happens is when you split the data 80-20 in 80-20 ratio, what happens is it is not splitting the data sequentially. Randomly it will split. Randomly it will go and pick up 80% of the data from your given data set. Remaining 20% data will be used for testing purpose. Okay. The random state equal to 42. What is that? So for example, if you don't specify random state equal to 42, what will happen is the X train, X test, Y train, Y test, right? Whenever you execute this cell more than one time, what will happen is each time it will pick up different data. 80% of the training data set will be randomly picked up first time when you click on this cell. And again, if you click on the run button here, second time what will happen, it will pick up different set of data. To avoid picking up different set of data, what we are doing is random state equal to 42. So when you run this cell multiple time, to make sure that the values are not changing it, right? We are using random state equal to 42. By nature, the values will get changed for the training and test data set. The reason is we are train and test data set, train and test split, we are using it. It is doing the random sampling. Okay. So for multiple run, if you want to use the same data, we are using random state equal. See, the simple thing is, uh, I have this notebook with me and I save it. And with this training and test split, okay, 80% of the data are randomly selected and remaining 20% of the data will be used as test data. With this data set, let's say now I'm going to my adjusted R square is 0.90. And then I say, hey, Priya, I have achieved the accuracy as 0.90. You are my manager, you found it really good. Okay. And when I share the script to you, and when you run this cell, and when you run the rest of the cells, right? What you will find is the model accuracy is 0.80 only, right? So even because here, if I don't specify random state equal to 42, you will end up seeing different things. So for that reason, we are going to use random state equal to why 42. You can specify any value, okay? But don't specify too much of values. If you specify, randomly some value, that is enough. So what will happen? This one random state will make sure that even with multiple runs, the output will remain same. That is the whole idea. Okay, I just click on it one more time. Yes, no issues. And next one is we are going to standardizing the numerical feature. Why do I need to standardize the numerical features? Why do I need to standardize the numerical features? The reason is there should not be any bias. There should not be any bias. Model should not biased with the column that contains higher values. The simple example is you have salary and age. Age column, how many digits you can have it? Maximum two digits, right? Let's say 3 digits. 100 years somebody lives, or 102, maximum 200 years, or 299 years. Okay. So maximum, 2 digits, right? Or 3 digits, not beyond that. Whereas the salary column can vary based on the level of the employee. Sundar Pichai, if you see his salary, it's too big. And if you see some staff, right, their salary is maybe right, they are 5 digit salary, 6 digit salary, 6 figure, 8 figure, 9 figure, 10 figure salary also they are getting it. Compared to the age column with your salary column contains huge values, big values. Hence, what will happen is your model will be biased towards your salary column. To overcome that, we scale all the numerical values so that all the numerical values will be falling between 0 and 1. Okay, standard scalar. So what we are doing is we have something called standard scalar function that is available as part of your which package. One second. A scalar, not pre-processing. Okay, one hot encoder. because the pre-processing is right, then nothing but that includes the feature engineering also. Okay, standard scalar, we are doing it. So here what I'm going to do is I'm going to standardize all the numerical features. See here, in this step, we have already converted the categorical variables and numerical variables. Don't think, false is there or true is there. It's not a 0 and 1. By default, right, the Boolean values true or considers 1, false is considered 0. Okay, that is what happened here. That one we did it. And next one is all these. Now, if you see here, right, not almost, all the input features now become a numerical value, right? So in this case, we need to do standardization. Okay. So here x underscore capital X. My God, my keyboard is not at all working. So please bear with me. Okay, I will get it fixed tomorrow. In the meanwhile, what I do is I just restart this thing. Okay, but don't leave this session. Okay, I'll be joining back. Okay, stay here. I will restart the system and it may take a few seconds. Okay, don't worry. What I will do is in the meanwhile, I will probably assign it to someone, right? Assign Dinesh. I'll assign you as the presenter. Okay. So once I join back, you need to send me back the It's still launching starting my kernel, Python. Let's wait for a few more seconds. Okay, I think it will be done in few seconds or in minutes. Okay. In fact, I have the external keyboard also. Even that keyboard also not working. External keyboard. My laptop keyboard, some keys are working, some keys are not working. Anyhow, don't worry. At least now I restarted my laptop. 1 second. I need to clean up all the things now. 1 second. I just. See here, I just showed you after you did after I did this standardized scaler, right? So how the values of your input features look like this. The values are, very minimal, right? Here, so it's all very, very small. Okay. Yeah. So what is the question? How does this standard scalar converted the features, huh? Okay, any formula is used? Okay, that's a good question. See here, what happens is it use something called x minus mu divided by sigma. Okay, x minus mu divided by sigma. Okay, that is the one it is using it. Okay, to scale the values. What is uh, x is your original value. Okay, in your data set, and then mu is your mean of your feature. For example, in the case of what is that? Years of service. Years of service. Let's say years of service is 5, and the average of that column is let's 6 or let's 3, right? So 5 minus 3 is 2 divided by sigma, the standard deviation. Okay, it uses the formula z score. There is called a z score normalization. Okay, z score normalization for each and every feature. It does the z score normalization. It is also called as a standardization. What do you mean by z-score normalization? Subtracting the mean of each columns or subtracting the mean of the column from your original value divided by sigma. Sigma is standard deviation. Okay, that is how the standardization has been done. The reason why we are doing standardization is the model should not get biased with higher value in any one of the columns. Okay, for that reason we have done it. And then what we did with the scaled values, right? We have scaled the values, all the numerical features. And then what we did with that scaled values, we are training the linear regression model. Here, what we are doing is we are using the class linear regression. We are using the class linear regression to initialize this one. We are initializing the class linear regression, this line. And then we are assigning to model. It's an object. Model.fit. Fit is a method. So here we mentioned about all the input features of your training data set, and then all the dependent variable values from your training data set we mentioned. So while training your model, we have to use input, the features and the output variable, or independent variables and the dependent variable. Since it's mandatory, right? We need to train the model with the training data set. What we are doing, we have splitted the entire given data into training and tested data set using train test split method. Okay, all the so wherever you see train, right? X underscore train, Y underscore train. The X underscore train contains the 80% of the randomly sampled values of your all the features, and Y underscore train is the 80% of randomly sampled your dependent variable values will be there. X underscore test is the remaining 20% of independent variables values will get stored here. Similarly, the 20% of the dependent variable value will get stored here. Okay, since we are training the model, we are going to use both the independent variables or the features and the output variable, and that belong to the training data set. okay, using fit method, okay. And then what we are doing is now my model get trained, right? Got trained with the training data set. Now we are applying this trained model on the unseen data called your test data set, the scaled test data set using predict method. So fit method, predict method, you need to remember it. This is common for almost all the supervised machine learning model. That is why, in one way, learning the machine learning is when it comes to coding, right? Very, very simple. So you need to train. For example, here it is linear regression. For example, if you are using decision tree, it's a decision tree regressor. That's all. Okay, and then fit method, training data set, and then apply the train model. Using predict on the unseen data. Fit method, predict method. You remember it. You're all set. Okay, that's all, guys. Okay, so we have trained the model using training data set, and then we applied this trained model called model on the unseen data, which is nothing but the test data set using the predict method. Predict and fit is the result word. It's a method. Okay, that is a predict. It's a, like a function. Okay. Okay, now we have trained the model and then we applied the trained model on the unseen data or the test data set. Next one, we need to evaluate how this model performs. Okay, using the metrics, we are going to evaluate it. There is a mean squared error function that is available as part of sklearn.metrics module. So, for this, we are going to pass the predicted value and then the actual value of my test data set. Okay, this is my test data set. The So in this case, an housing price, right? The price belongs to test data set, which is nothing but the actual price and then predicted price. Look here, we have stored the predicted price for the test data set, right? For all the independent variables, we passed it. So now what happened? The y underscore predict will contain the predicted housing price, the dependent variables value. Predicted values of your dependent variable will be stored here. So this one is your test data set, predicted values. That is what this one. And then you are going to pass the y underscore. This is your actual value. This is your predicted value. You are passing to mean square. If you subtract the actual from your predicted actually, if you subtract your predicted from your actual, you will get the error, right? And then if you take the mean of them, that is called mean square error. That value will get stored here. There is a function, it takes care of it. Okay, it takes an average of the square error, everything. We don't have to do it manually. It squares the error. So if you say, basically what happens here is the predicted value will get subtracted from the actual value, and then it gets squared for each and every record, and then it adds all the things, and then it takes this the mean average of that one, and then right. So that is called mean square error. That value will get stored here, and the R2 score is the same thing. Okay, the actual minus predicted. You pass that one. Actual and predicted value pass to R2 score. There is a R2 underscore function that is readily available. It's a built-in function. Good. So now if you want to print all the thing, right, on the R2L in MSC, I mentioned it at the bottom. If you see here, the R2 score is 69, okay, 0.70. It's not bad, it's okay, okay, but still requires some kind of improvement. The error is this one. And then the coefficients, okay, what is the intercept and the slopes for each input features we could see here, right? That is what we can see. So for the column PhD, this is the, what is that? Intercept is this one, okay, and then the uh, this is the one is for the PhD and then service associate assistant professor, okay, and rank professor. For each and every rank, and including the male or female, right, it gives me the uh, salary part. Okay, sorry, it gives me the coefficients, beta coefficients. This is your beta naught, and this is your beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. That's all. Okay, so that is the one. If you plug in this one into your input feature, sorry, if you plug in this one into not input feature, if you plug in these values in your equation, multiple linear regression. Okay, 1 second, I'll just show you my PowerPoint. So there I mentioned about the equation, isn't it? This is what we discussed at the beginning of today's session. The equation I explained about. I just plugged in all the values in the equation, right? This is the mathematical equation. Beta naught is your intercept. In this case, what you see here, here drop first equal to true we have given. Hence, the one category is not there. So here we can see the assistant professor and professor. The associate professor is not there, which is nothing but the average salary drawn by the associate professor is this much. Okay, intercept is nothing but so because in the rank column we have three categories. So we have used drop first equal to true. What happened? In this case, randomly, right? It dropped the associate professor and it created n minus 1 columns for the remaining two categories, which is nothing but assistant professor and professor. For associate professor, there is no column got created, which is nothing but your intercept value. Got it? Now we have trained the model and then we applied the trained model in the test data set. And then we have just seen the explored the metrics for each and everything, right? And also, yeah, so now the question is, yeah, what is the question? Hmm. Yeah, that is what. The standard scalar is different. Okay, don't worry about that. Yeah, we standard is the values, correct. So for that, yeah, I have used this z-score. Z-score is the formula for z-score. Z-score is x minus mu divided by sigma. Any questions so far? Yeah, interpreting this output, using this one, right? It is little bit different. The way, we have interpreted in the very first session. The very first session, right? It was very simple because there was no categorical column were there, right? Initially, we did not discuss about any categorical column, but here, we have discussed about the mix of the features, which contains both the numerical as well as the categorical values in it. So we have used the one-hot encoding, and then I justified you why one-hot encoding was used. Yeah. Yeah, now the question is very good. So there was a beautiful question. So how do I, or let's how do I justify or how do I explain what salary was drawn by each employee by their rank, as per their rank? Excellent question. Okay. Okay. Here, this is the intercept. I just copy all the values. We don't need mean square or R square to do that. Anyhow, I just copy it because here keyboard issue and other thing. What I will do is I just remove these two things. This is my intercept. Rest of them are my, what is that? The rest of them are my features, right? Features. So here, what was the salary drawn? If somebody is asking, what was the salary drawn by the associate professor? This is the salary drawn by the associate professor. Okay. This is the baseline sample. Okay. And sorry, this is the baseline salary. Okay. Baseline rank. We call that as a baseline rank. In this case, the associate professor. Okay. In this case, what happens is the associate professor salary is this one plus so in this case, sorry, in this case, what happened? The assistant professor salary is zero, and then the professor salary is zero. When these two are zero, That means, right, you are left with what? The associate professor's salary. You remember I explained you previously. Let's say three departments are there. What I did, I created only two department related columns. See, I have a column called department. I have A, B, C. What I did, did the one-hot encoding. As per the one-hot encoding, in the case of department column, though we have three categories, we have used drop first equal to true. Hence, what happened? It dropped over the. Assume that the A department got removed. For the remaining two categories, two columns got created. Two categories, two columns got created. B and C. Okay. If both the columns B and C contain 0, that means that person belongs to department A. Similarly, here, if assistant professor is 0 and rank professor is 0, that means, let's say on the first record, right? The first record person, the column will have, let's say, assistant professor 0 and rank professor 0. So in that, this is, see, guys, this is a coefficient value. This is beta naught, beta 1, beta 2, beta 3, beta 4, beta 5. This is not the assistant professor, value, okay? These are the coefficient, okay? So this is something like, I just write it here. So this is the thing here. Look here. You just think, where is the rank? Here, right? Beta 1 into the rank associate professor. So beta 1 is, let's say, your beta 1 is -2574. And if this person is 1, rank will be 1 here, right? Here, let's say, we have 1. This is very important. You need to understand thoroughly this one. Otherwise, you will get confused. Unfortunately, other goes wrong because of my ego issue, right? Yeah. So here, for example, the first record in your data set contains, is a, let's, that person is, rank is 0. Okay, rank is 0. See, I just write it here, beta naught plus beta 1 into professor rank plus beta 2 into assistant professor rank. That's all. Associate professor, we got excluded using drop underscore first equal to true in my get dummies function, okay? Plus the rest of the values, okay? And here the beta naught is something like 1 lakh something, right? 107,648, something like that, okay? So here, let's say, in the first record, in my data set, and contains, this is 0 for the professor rank column, and assistant was 0. So beta 1 you have some value, beta 2 has some value. 0 into this one will become 0 only. 0 into this one will become 0 only. That means, your intercept is 107. What does it tells us? This first record guy is neither a professor nor an assistant professor. That means he is an associate professor. This is the baseline rank. This is called baseline rank. This is how you need to interpret. So now you understood the intercept plays an important role in the case of one-hot encoding. Previously, I told you the intercept, in some cases, it doesn't make any sense. For example, the size of the house is 0, but my intercept value is 1356. If I don't buy anything, do I need to pay 1,000 or let's say 10,003, something like that? In that case, intercept does not make sense. But there are some cases intercept makes sense. When it comes to one-hot encoding, obviously this one is really, really helpful. The intercept is really, really helpful. This plays an important role. Okay, if somebody is asking you, what is the salary drawn by associate professor? You can say 107,648. Okay, if somebody is asking you, what is the salary drawn by assistant professor? Okay, assistant professor. So in that case, for example, in that case, what will happen? Assistant professor is, the second record will contain 1, and the professor will contain 0 here. This one will become 0, plus your this value will be there. So in that case, you need to add this one with this one, this one, okay? You need to add this one with this one. For example, in this case, the second record, we are talking about the second record. Guys, forget about 0, okay? Second record, is an assistant professor, hence this column will have value 1. Is not a professor, hence this one will become 0. But you have an intercept here. Okay, in that case, in our case, what value we are getting it? 1 second. Hmm. Yes, if you see here, in that case, see associate assistant professor minus 256. If somebody is asking what is the salary of assistant professor, that means the professor column will have 0. See, guys, this is beta 2 value. Okay, beta 2 into the professor column contains 0. So 0 into 0 will become 0, right? So we are left with assistant professor and then the intercept. You need to add these two values to get the assistant professor salary. That means you need to subtract this value from this one to get the assistant, because it's a negative value, right? So this value minus this one, that is the one will give you the assistant professor salary. That means the assistant professor is getting 2,574.23 dollar lesser salary than the salary drawn by the associate professor. Got it? If I ask you what is the salary drawn by the professor, can someone tell me what is the salary drawn by the professor? The professor is 13902, right? Guys, come on, please concentrate here. If you say you don't understand, that means you're not concentrating here. Here, so this means the first record here, the first record, you have, let's say, Krishnamurthy, okay? The first employee in your data set is Krishnamurthy. Krishnamurthy is neither a professor nor an associate professor. Then, this one will be 1 only. But maybe let's this is a beta 1, beta 2, beta 3. Okay, forget about this column because, yeah, in our example, we have used this as a baseline column, right? In your data set, you have only these two columns. In addition to that, we intercept. Beta naught is your 107650. You remember 107650. Okay. So if you have 00 here, let's this is Narayanan, right? Narayanan is neither a professor nor a assistant professor. Though assistant professor has some value here. Look here, assistant professor is 2574. 2574 will come here. That is the beta coefficient value, slope value for assistant professor, minus 2574 into 0 is 0. And similarly, if you come here, the professor's salary is 13902. 13902 into 0 is 0. We are left with what? We are left with only one, the intercept, that is nothing but your associate professor. புரிஞ்சதா இல்லையாப்பா? இந்த ரெக்கார்டு வந்து நாராயணனுடைய ரெக்கார்டு. நாராயணன் வந்து அவர் ப்ரொஃபஸரும் கிடையாது, அசிஸ்டன்ட் ப்ரொஃபஸரும் கிடையாது. அப்படின்னா என்ன அர்த்தம்? அவர் வந்து அசோசியேட் ப்ரொஃபஸர். அசோசியேட் ப்ரொஃபஸருக்கு வந்து என்ன இங்கே இஸ் நத்திங் பட் தி இன்டர்செப்ட் வேல்யூ இஸ் நத்திங் பட் த அசோசியேட் ப்ரொஃபஸர். த பேஸ் லைன் ரேங்க், திஸ் இஸ் கால் பேஸ் லைன் ரேங்க். தட் மீன் நீங்கள் கேட்கலாம், இதுக்கு வந்து இதுக்கு வந்து கன்ஃபியூஷனுக்கு பேசாமல் நம்ம 3 காலம் வச்சுக்கலாமே. 3 காலம் வைக்கலாம், பட் நம்பர் ஆஃப் காலம்ஸ் வில் பி மோர், ரைட்? More number of column will have, you will have more number of columns if you have in your data set. It will be an headache, okay? And other things, it can lead to some kind of multicollinearity. For that reason, what we are doing is we are creating n minus 1 columns from your categorical column. Okay, in your categorical column, let's say you have 3 categories. Nalla kelinga, 3 categories. For that, you need to create for that you need to 2 columns only for the 2 categories. If you don't create another column for the third category, so that implies, right, for example, B and D contain 00 means that belongs to, that person belongs to department A. புரிஞ்சதா? Is it clear or not? So in this case, the assistant professor's salary is, so what will happen? This is the beta coefficient. This is a, let's the beta 2 ன்னு வச்சுக்கோங்க. Beta 2 into the rank assistant professor காலத்துல 1 ன்னு இருக்கு. 1 into this one is 1 and the professor columnல 0 இருக்கு because that person is a assistant professor. Hence அந்த for example சரஸ்வதி இருக்காங்க. சரஸ்வதி is an assistant professor. அந்த assistant professorங்கிற காலத்துல 1 ன்னு இருக்கும். professorங்கிற காலத்துல 0 இருக்கும். அப்போ 0 into this value will become 0 only, right? This is a beta coefficient, guys. Okay, wow. So here assistant professor is minus, in this call assistant professor காலத்துல வந்து 1 இருக்கும். So for that rank assistant professor, the beta coefficient slope value is this one. This slope value into that 1 is minus 2574 plus intercept. That is the one is the salary drawn by the assistant professor. This value subtract by this one. That is the one. But associate, in that case, we can make out clearly here the assistant professor salary is more than the associate salary. Associate professor salary is more than the assistant professor salary, and then rank professor salary is more than the associate. So you need to add these two things because it's a positive value here. So the professor is obviously getting more salary than the rest of the two categories of the professors. Okay. Plus you need to add the remaining thing. Okay. So that is the one. We'll give you that one. You got it? Is it clear? If somebody is asking you, can you please explain me the salary drawn by each faculty members based on their rank? So you can say the associate professor salary is this one. And in the case of assistant professor salary is, obviously this one will become 0, right? இல்லைன்னா இங்க போட்டு காமிச்சிடுறேன்ப்பா. For example, the employee name. Okay, keyboard problem. Employee name. இல்லைன்னா சிம்பிளா போட்டலாம் because my keyboard is started. Employee name, age இருக்கு. You have age, comma, இங்க வந்து rank, age, rank, assistant professor. Okay, இல்லைன்னா I just use the thing so that notation. அப்புறமா பார்த்தீங்கன்னா you will have something like rank professor. Simply plug in the value. அவ்வளவுதான். இது வந்து you can also try it from your Excel so that you'll be able to understand very clearly. So we have got everything. And then in the next line, if I can employee name is, let's Narayan. Okay. And his age is 45. And he's our assistant professor. He's an assistant professor. 1. He is not a professor. Hence, that professor column will be 0, right? Comma, discipline maybe, right? He is B. Discipline B is true. True na 1 ன்னு போட்டுக்கலாம். And then the sex male na true. Right? True is 1, right? So if you see here, 45 is the age. Forget about age, right? We did not use age in this data set. இப்போ இந்த டேட்டால பார்த்தீங்கன்னா rank associate professor இல்லையா, what is the corresponding coefficient value? -257. That is, you just think that is your beta 1, okay, which is nothing but your -2574 into 1. The 1, see, remember the 1 is the value that is there in your column called assistant professor. Using 1 or 0 only, you can decide whether Narayanan is a assistant professor or not, right? And this is the beta coefficient value. That is nothing but the slope for the column assistant professor that is computed by my model. And then the rank professor, in this case, is 0. But professor is 13902 into, 13902 This is nothing but my beta 2, which is 13902. Yeah, you're clear, right? Okay, good. Priya is clear. And how about not Priya? Yeah, Sasireka is clear. Okay, Danya is clear. Okay, very good. So, and the next one is, let's know discipline, right? Discipline is 9843 into அந்த மாதிரி வரும். ஓகேவா? Is a male, is a 2697 into this one. So, and then this guy is an associate professor, hence the associate rank associate professor column will have the value 1 in it. This column is, since he is not a professor, 0 will be there. So what will happen is, in this case, the corresponding slope value will get multiplied with this each and every column. So if I ask you what is the salary drawn by the assistant professor, so this 0 into this one is 0. Forget about the rest of the columns. Okay, 0 into this one is 0. The professor will become 0, right? This, because the value that is there in the rank professor for Narayan is, because he's not a rank professor, 0. 0 into 0 is 0. 0 into this value is 0. Now we are left with minus 2574 plus the intercept. So, right. So if you subtract this value, that is what the salary drawn by Narayanan. And similarly, next you have some other employees. Is the next record you have Krishnan. Krishnan is neither a professor nor a assistant professor. That means he's an associate professor. His salary is this one. And next record is Shiva. Shiva is a professor. Hence, what will happen is here 1 will be there. So 1 into 13902. Here it will become 0 for Shiva. Okay. Hence, 1392 into 1 is 1 plus this is the 1. Okay. That means professor's salary is more than the salary of assistant professor. And obviously, associate professor's salary is more than assistant professor, but less than the professor's salary. Got it? This is how you need to interpret, guys, in the case of one-hot encoding. And also explain to clearly what is label encoding, all the things. Okay, to summarize, we discussed about how to, what is the objective of, what is the problem statement of this, today's demo session. And also we discussed about what is the business objective, how to convert the problem statement to the machine learning problem. And we have seen, we discussed about the independent variables, and then which is nothing but the features, and then the dependent variable was salary. Since the dependent variable salary was a continuous variable, it is a regression problem. Hence, we have used the linear regression algorithm to train the model. So what we did feature engineering, because we have a mix of both categorical and numerical variables were there as part of my features. What I need to do is I need to convert all the features values into numerical value. So in that case, the categorical columns, what I did, I just grouped it separately, and then I used the pd dot get underscore dummies, right? Get underscore dummies function, using which we have what we did, right? We have mentioned right here, we mentioned the data frame name and then categorical features in all these things. Drop first equal to true. So what get underscore dummies does, right? So in this case, it created something like this. It created something like this for the rank column. Similarly, for discipline and gender column, it created column something like that. So in that case, what happened when you see the rank column, not like this. Okay, yeah, rank assistant professor, rank professor, not the associate professor, right? It's because we have used raw first equal to true. So in that case, what happened? Only the 2 columns were created for this specific categorical column alone, assistant professor and professor. Okay, and then the baseline value, the baseline column, the reference column is nothing but the associate professor. That means your intercept. Okay, and then the discipline also, it did the one-hot encoding. Discipline B, wherever you create a discipline B column, instead of creating, because the discipline column contains 2 values, 2 categories, A, B. Instead of creating 2 columns, it created only 1 column, B. So whichever records, whichever employees discipline B was true, that means that person belongs to B. False means that person belongs to discipline A. Okay, that is what it implies that. So again, sex equal to sex underscore male was there. Sex underscore male. Whichever records that contains one in true, that means that person is a male. Otherwise, false means he is a female. Okay, 1 and 0, true or false. Okay, that is how the p dot dummies function was helpful in terms of converting the categorical features into numerical features, especially the binary values. Okay, and then what we did, we have created two variables. Each variable, so this variable, the first variable was holding all the input features, second variable was only one dependent variable. And then what we did, we have used a train test split, using which we have splitted the data into training and test data set with the ratio of 80-20. 80% of the data were randomly selected for test data set, remaining 20% data were considered for test data set. And then we have standardized. So now, as of now, right, we are having all the features are in numerical features, and we have split in training test data set. Now, after splitting the training test data set, we are using standard scalar, using which we have converted all the numerical values into z-score values. What is the formula for z-score? Z-score is nothing but x minus mu divided by sigma. For each and every, for example, the Narayanan, the years of X means 5, and the average of the years of X means that column is, let's 3. The 5 minus 3, 2 divided, let's here sigma is 2, 2 divided by 2 is 1. Okay, the standard, we have used the standard scalar. Standard scalar uses the z-score technique to transform your numerical features into z-score values, so that all the values will become small, so that the model will not get biased with any specific column that contains higher values, right? So next one is, yes, we did features engineering, and we splitted the training test set. The next one is we trained the model with the training data set, and then we applied the trained model. In this case, the model name is model. With trained model, we applied on the test data set using predict method. Okay. So all the predicted values will get stored here. So all we did here in this line is we just showed only the all the independent features, all the independent test data set to my model. My model for the given test data set independent variables, it predicted the housing price. Okay, predicted housing price got stored here. Next one is I just evaluated my model performance. For this, I just passed the actual and predicted value to the mean squared error, to get the mean squared error value, and then R squared value, R2 underscore score. Even for this, the actual and predicted value you need to pass it from your test data set, because test data set only we are applying the model, trained model, right? Okay, so to know how well my model performance, you need to apply the model on the unseen data, which is nothing but test data set. Okay, with the test data set, if a model is performing well, then it is good. Okay, so for that reason only, you can see test here. Okay, and then we are checking the intercept value, and then this one gives me all the coefficients, beta 1, beta 2. This is your beta naught, and beta 1, beta 2, beta 3, whatever the number of columns. For example, you have 7 input features are there. For each input feature, you have different beta values will be beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, beta 7, right? Something like that. This is your beta naught intercept. So using this function, we can get everything in a single. We got all the things here. And the next thing is, yes, intercept. We are printing the intercept and coefficient. The for loop is helpful to combine these things, right? It gives me the feature name, along with that the coefficient value, and then mean square error, everything. This is pretty simple. It's a simple for loop, all the things. Okay. And next one is how to interpret the model. That is what very much important. So as of this line, your business people or the management, they do not know what the hell all these things. All they need you is to help them to understand the output of the model. If they ask a question like what is the salary drawn by, what is the salary that we can give it to Narayanan? He's a newly joined guy. His age is 45. He's an assistant professor. And what will happen? Professor is 0 and discipline is 1 into this one, and the male is right. So in this case, if they ask you what value, what is the salary that we can, you need to subtract this value from this one, right? Subtract. So you can tell the assistant professor salary is less than your associate professor. That is the salary. And then the professor, if listen, I have another professor. So in this case, it will be 1 here. This one will be 0. And then here 1 into this one, 13902 plus this one. That is the salary or salary drawn by your professor. Got it. So this wraps up the today's demo session. It's already 11:46. Sorry, guys. Even from my side, due to keyboard issue, I had to restart my laptop. If you have any questions so far, what you do is watch the video and then you do it. I will send you one assignment. You can start work on the linear regression